It's not enough to quote William Lyne in citing Tesla having spoken the words, "For every 200 pounds of iron added to his special generator, 1 horsepower output would be added to the already prevailing output." It's also necessary to come up with a speculative guess estimation of how. How can that be? And what makes it very intriguingly difficult to formulate an answer is the fact that the voltage, eventually, it doesn't take long, is evenly distributed throughout the entire circuit, so how can you get a voltage difference and any kind of current to arise? Well, the answer lies in Eric Dollard. He has specifically attempted to correct our misdiagnosis of how a lightning bolt forms. He said it doesn't form in the clouds or from a voltage difference between the clouds and the earth or between two clouds. It actually forms radially surrounding the pathway it's going to take and then gets sucked into that pathway from the outer perimeter inward towards the center, kind of like well, he didn't use this example, but I think it's appropriate, a ballerina or better yet, an ice skater. She's spinning around, but she has her arms extended wide, or a guy, and she draws in her arms closer to her spin axis, namely her center, and her rotation speeds up very dramatically. Well, this is kind of like the electrostatic cling action of, because what we have forming around the future pathway of a lightning bolt is a capacitive, we think of it as a capacitive discharge, but it's actually a capacitive charging that occurs prior. And it's not the charging in the cloud and the earth, let's say, but it's in the air surrounding the future pathway. And because it's charging, it tends to attract itself to itself and draw itself into more concentration until finally it's concentrated along the pathway. And then you get the dielectrical breakthrough, the voltage breakdown of the air, causing the arc to form, punching a hole through the dielectric of the air. Of course, it's preceded by an ionization channel, but be that as it may. So what if the same thing happens in a magnetizable material such as a ferromagnetizable substance that we know commonly as iron? What if we subject a mass of iron to an electrostatic field? What do you think the consequence will be? There has to be a consequence. What do you think it would be? Same thing as the formation of a lightning bolt in air will be the formation of a magnetic bolt or surging pathway through the iron. In other words, we don't need a voltage difference to create current and thus the movement of voltage from one place to another. All we need is a strong field surrounding a future pathway. And if the pathway is not magnetizable, then the only outlet is an arc. But if the space in which this field is forming and concentrating itself is magnetizable, in other words, in this case, made up of iron, a mass of iron, then that space filled with the iron material now becomes a magnetizable pathway for a magnetic arc or short to occur. And oddly enough, I will speculate that the voltage difference forms as a consequence of the arc, not as a cause. In other words, everything is backwards. It's not to say that you can't form an arc by creating a voltage difference between 2 points in space, but to say that it's a one-way direction of causation, a one-way conceptual direction of cause versus effect, I think that's where we make our mistake of judgment. It's bidirectional. Either way, it works. It's not bidirectional at the same time. In fact, the formation and the arcing of a lightning bolt tends to create a second bolt that goes in reverse direction. Now that makes sense, but see, now that's the discharge of a voltage difference. So that happened after the first lightning bolt had already formed and taken its pathway. So you see, we have to understand these dynamics of a lightning bolt in a thundercloud in order to understand why William Lyne could quote Tesla the way he did and why Tesla is correct, barring any evidence. You know, how do you go about testing a theory if you don't even know what you're looking at, if you don't understand what's being presented to you? There's no way you're going to be able to formulate an experiment because you won't even know how to begin. So I suspect this is the case, is that it's bidirectional and it tends to ricochet back and forth in terms of bidirectionality. It's just like an AC circuit, really. So we could produce an electrostatic arc or a magnetic arc. The traditional theological way of thinking about it is to create a voltage difference in the case of an electrostatic arcing, or a magnetic difference, you know, a north pole and a south pole, to create a magnetic arcing between the two poles, an arcing of current, as opposed to an arc of voltage. Either way, we could create a voltage difference, or we could simply produce a field, a monochromatic, or I should say an evenly distributed field, more or less. There's always going to be slight deviations, and it could be the slight deviations that map out the pathway of that arc. In fact, we know the arc from experience. Now this we know. It tends to branch, which shows that there is no distinct 2 points of voltage difference. It's scattered and somewhat, not evenly, but distributed at numerous points, all contributing to the pathway of the arc. Which means that if you do this in a magnetic medium, you're not going to get a north pole and a south pole that's actually distinguishable. It's going to be kind of fuzzy. It's going to be kind of spread out a little too much to make a specific determination. Okay, this is the direction of north, and this is the direction of south for this magnetic field. You're not going to find that. It's going to be fuzzy, and it's going to be randomly flipping around. In fact, now that I think of it, what if the magnetic field is created in the shell of the hollow earth that we stand on, but it's an electrostatic charge in the center of this one-sided capacitor that's driving it? That makes sense. Definitely. Interesting. So, just as I've suspected for quite some time now, current is a local phenomenon, while voltage, or dielectrical transfer of voltage, is a much more pervasive phenomenon that is literally galactic in scope. But when we think about current, we need a pathway of conductance, and space is the worst medium for that. And we have everything we need on Earth for conductivity. We've got the breakdown of air, the dielectrical of air. We have the iron layers inside the Earth. We have the convective, moist layers of soil at the surface of the Earth. We have got water in the ocean, salty water no less. So there are plenty of excuses for current to flow, but not enough excuses for voltage buildup unless the Earth is hollow, and unless all stellar objects that are spheroidal or ellipsoidal in shape are also hollow. That includes stars. That includes the hub of a spiral arm galaxy. That includes the center of an elliptical galaxy. Anything spheroidal. Now, one of the moons of Jupiter is not spheroidal. It literally looks like a rock, and it probably is a solid rock. But everything else that's spheroidal is probably hollow, including our sun. Because it makes sense that this is the only way voltage can, or energy in the form of voltage, because there is no other way, to transfer energy across the dielectric of empty space unless it's strictly a voltage transfer between celestial capacitors. Instead of calling it celestial objects such as stars and planets, just celestial, capacitive stellar objects. Okay, so getting back to magnetizable iron, if we subject a very massive amount of magnetizable iron to an electrostatic field, doesn't that start sounding like a mag amp? I mean, not exactly the same, but pretty close in principle, thematically speaking. But instead of charging up a magnetizable mass with a magnetic field to saturate it, such as charging up the core of a transformer, let's say, with coming from an exterior source of magnetism. Instead, we charge it up with electrostatics. Maybe not so efficient, but when you've got so much voltage, and it's the easiest thing in the world to create excessive voltage, it's hard as hell to create current. So instead, you choose, okay, let's take the path of least resistance. Let's charge up a field with lots of voltage, and then take that massive voltage and subject a magnetizable mass to that massive voltage. We might start seeing some flashes of current rippling through the inside of that magnetizable mass, creating flashes of a magnetic field emanating out of that chunk of iron, or ton of iron in our case of what we're trying to stipulate here. It's probably could happen. And if you have a circuit nearby that serves as a waveguide for current to flow, now you've got your magnetic field generated by your magnetizable iron mass that's being provoked by an electrostatic field. Now you've got the inducement of current along the pathway of that circuit. I mean, it doesn't sound too far-fetched. It's slightly convoluted in the machination of imagining how that machinery, that electrodynamic machinery, is taking place. But it's not that hard to get it. And in all probability, there's nothing that anybody could say against it, because it's a possibility that is probably possible. It has, I can't think of anything that could work against it. So this would explain why Tesla would take that route, because he understood the easiest thing in the world to create when we're talking about free energy is to initially create only half the picture, the voltage. And then initially you set up your environmental conditions such that when you apply, when you reap the benefit of all that free voltage, that you'll get some current to come out of it somehow or another. And in this case, we've got 3 steps we have to proceed in. We create the voltage, apply it to a magnetizable mass, and then have a circuit nearby serving as a waveguide, and also as an aerial to not only pick up that magnetic field, but to guide it within specific pathways through various components to have a very specific effect. In my case, what I'm trying to imagine, how do you power an electromagnetic motor with an electrostatic field? Well, this is how to explain it, to make it happen. So, other than dropping my phone in front of my face, so you're going, oh, what's this? What are we looking at? Because I'm not looking at my cell phones. That's why you're looking at my nose hairs or pimples. So I guess that's how to explain it. And it makes so much sense to me now. I've finally answered my own question. And with the assistance of William Lyne. He's taken really a bad rap for sticking his neck out. And it's unfortunate, but that's usually the way it works. As he commented in one of his emails to me 6 years ago, no good deed goes unpunished. That's the way it is, huh? Okay, well, to end on that sour note, and he was I won't tell you what he was referring to because he may have bragging rights, but it's a bit off topic, so I'll try to stay focused here. Okay, solve that problem. Now we know how. How to use an electrostatic field of energy. Don't think in terms of an electrostatic motor. That's bullshit. Don't even go there. That's a simpleton brain not looking at the problem correctly. And all we had to do was go to the assistance of Eric Dollard and lightning bolts. Zeus. We should call him Eric Zeus. Or Zeus Eric, I don't know. Zeusy Eric. Okay, enough.